All right, everyone. The point of this video is two reasons, actually. We're going to talk about a strategy that I want you to use all year long in my class to solve just about any problem that I give you. Specifically, we'll apply it to some questions about displacement and distance and things like that. But this is a strategy I want you to use all year long. So here's a list of the steps that I want you to follow. First is just read the problem. If I give you a word problem, read it carefully. Then read it again, and then underline the numbers and the units. Then I want you to draw a model if you can. List the known variables, list the unknown variables, and then based on that, you might be able to choose an equation that would help you find the unknown variable. Once you have the right equation chosen, you can substitute the numbers in that you have and do some math to solve the problem. And then check your work. Make sure that the number makes sense. Make sure that it's not some crazy high number, crazy high speed, or whatever we're trying to calculate, and make sure your units are correct. All right, let's start with this problem here. So let's read the problem. A person walks 3 meters to the right, then 7 meters to the left. Draw two vectors for their movement, calculate distance and displacement. All right, so let's read it again, and let's make sure that we've underlined numbers and units. So I've already underlined right here, we have 3 meters. All right, that's a number and a unit. And then we also have 7 meters. All right, that's underlined. All right, I'm going to watch out for the fact that this says right and this is left. Those are going to be important terms for us. Remember, direction matters in physics. And there are some terms that we call vectors that have both a magnitude and a direction. So we need to be clear about which direction we're moving. All right, now I'm going to draw a model. So like I said, direction matters. So I'm going to make sure that my model is correct. I'm going to have 3 meters to the right. And that can just be drawn with a vector like this, just an arrow to the right. Now I need 7 meters to the left. So I'm going to pick up right where I left off with that other arrow, and I'm going to go 7 this way. And it's just an estimate. I think this is, a lot bigger than this one, and that should make sense. This one's 7, and this one's 3. Okay. Now I want to draw the two vectors. Oh, I did that already. Okay, so I drew my model. Now I want to make sure I list my variables. So I have a couple of movements. All right, so I'm going to label these. All right, so my first one, I have a change in position of 3. So I'm going to call it delta x1, my first change in position. The next one I'm going to call delta x2, and I'm going to call it -7. And I'm going to make sure I put my units here. These are meters. All right, now I want to list my unknown. My unknown, I don't know the total displacement. I also don't know my distance. So I like to put question marks there for now. All right, so I've done this step. I've listed my knowns. I've listed my unknowns. Now I want to choose an equation. Well, I know that distance is just all the numbers added up together. So I could say that, distance is, distance 1 plus distance 2, and there's no negative numbers here. All right, delta x, my total displacement, is the same thing. It's going to be delta x1 plus delta x2, all my displacements combined. All right, so those are my equations. I'm going to substitute in my numbers. So my distance is going to be 3 plus 7. I'm just substituting in my 3 and my 7 for D1 and D2. So that's going to be 10 meters. Delta x is going to be very similar, except I'm going to do 3 minus 7, because that minus is only important for displacement. Displacement keeps track of directions. So 3 minus 7 is -4. Okay. So I chose my equation, I substitute and solved. I put in the numbers that I was given, and now I have my final answer. I have distance is 10 meters, but displacement is -4 meters. And now I'm going to check my work. Now, does it make sense to have these numbers? Does it make sense for me to think that this person has gone 10 meters? Well, yeah, based on the problem, that makes sense. If you got an answer that was like 30 meters, you might want to check yourself. Also, my displacement of -4. Does that make sense? Yeah, because I started here. I started here and I ended here. My final position is to the left of my initial position. So it makes sense to have a negative number here. So that's what I mean by check your work. Make sure that the numbers make sense based on your model that you drew and based on the problem you were given. All right, so these are the steps I want you to follow when I give you a problem. Okay? Try to use every step. Depending on the problem you're given, you might be able to skip a few steps. But overall, these are the steps that you want to follow. Sometimes you might not have to draw a model, but these are the steps that we should make sure that we're trying to follow. Make sure that we have listed out things carefully on our paper or whatever you're working on. All right, I want to be able to clearly see, do you know what variables you're dealing with? Do you know what equations to use? And then did you do your math correctly? I need to see that when you are giving me your work. All right, so to make sure I understand what you did and that you understand how to solve these problems. All right, I hope this was useful.